Alrighty, CNT140, we're continuing on Chapter 10. We're looking at our next termination, our outlet jack termination. So this one, going to look very similar to a lot of the terminations we've done before, but let's go through it. First thing we'll do is we'll take our cable, trim it to length, strip a little bit of insulation off, separate our wire pairs out like so. Once that's done, I'll take a second to orient myself to the outlet jack we're working with. And I put pictures here, ones that we typically end up working with. I'll take a second to orient myself to how the color code is marked, pay attention to that. I'll also try to orient myself to how it's being terminated. In this case, the wires are being fed into this little piece on the back, and then that slides onto the jack. Okay. Again, look at my color code, make sure I understand how it's being done. Then I'll take my cables or wires and prepare them, feed them up through the connector, start untwisting them, and then fit them into the notches on the jack according to the color code. Watch the color code, watch the color code, watch the color code. If you remember when we did it, the first time I had a marker and I wrote over top of the color code I was not using. That way I did not confuse myself. So pay attention to the color code and the wires and where they go. Once they're in the proper spot, we used a termination tool like so. There's other ones out there for different jacks. Lay your jack in there and use the termination tool to, in our case, fit the red slide part on top of the jack. Fit those two pieces together. So I use the termination tool to basically crimp it shut. Then I have a complete outlet jack. Yay! Okay. There's my outlet jack termination. For my Rj45 termination, again, this would be our patch cable, our stranded cable patch cable termination. So here's my stranded cable. I'm using an Rj45 to make a patch cable. Okay, just kind of reminding you. Again, trim the cable to length, strip a little bit of insulation off, separate the wire pairs. I'm going to separate them, and I'm going to carefully, again, pay attention to my color code, 568A, 568B color code. I will lay my wires out in color code order. This is a 568B cable as you look at it here. I'm going to gently flatten out the wires. Okay. Once they're flattened out, then I'm going to trim them the length till they fit in the outlet jack. If you remember, two things need to happen in the outlet jack, or the Rj45. The little wires need to make it to the end of the connector, and the insulation needs to be seated in the connector that when you crimp it, the Rj45 actually grabs a hold of that jacket, grabs a hold of that insulation. So I will, once I cut it to length, remember I'm cutting that straight across, I'll feed it into my Rj45, fit the Rj45 in my crimper, give it a crimp, and then do a visual inspection and make sure, again, these little wires make it to the whole way to the end of the connector, and my insulation makes it in here far enough that as I crimp, the little triangle that's here grabs a hold of that jacket so it does not slide out. Okay, there's our Rj45 termination. Now, the next little section, they do talk about some testing. So reminding us, this is our horizontal cabling structure. Closet, patch panel, horizontal cabling out to outlet jack, patch cable out to computer. All this is wired straight through. All of this is wired straight through. And it's wired to a color code like 568A or 568B, depending on your facility. My outlet jacks, again, wired 568A or 568B, depending on your facility. As I hook my continuity meter up, it's looking for all of this to be straight through. So if all of this is wired as we're saying out here, everything wired straight through, when I hook that meter up, it's going to indicate pass. All four wire pairs are connecting. My little wire mapping meter is going to indicate a straight through wire map. That's what we want. This is all normal. So if I'm now going to try to locate a fault, when I hook up my meter, my little continuity checker is going to basically tell me, do I have connection? The wire mapper will show me what's connected to what. It's going to give me a wire map showing me this pin is connected to this pin pin's connected to this pin. Between the two of these, I can usually locate 9 out of 10 cable problems that I have. So these two are really vital for our troubleshooting. If I have to keep digging for a cable problem, then I start using my certification meter. These are the ones that are actually testing for performance issues, like impedance, near-on crosstalk length, attenuation sort of thing. They're the only ones that can test for that, so they're the only ones that are going to find those issues. But most of my problems are a wiring issue that I can catch with a continuity checker or wire mapper. All right. With that being said, then, they remind us of the wire maps. Here's some common wire maps that we run into. Well, let's go through these real quickly. If I have a wire break, it's because one of the wires is not making connection. And that could be it was not terminated well, or it could be that it's broken somewhere along the line. So I would need to identify where. Well, the first thing I do is, again, here's my normal wire map. When I hook up my wire mapping meter, it's going to show me a particular wire is not connected. Okay, my continuity checker is going to show me a particular wire pair is open. And here again is my little wire mapper. As I look at it, it shows me wire 4 is open. Now, this could be occurring at either end of my cable run, or this could be occurring in the middle. If it's at the end, usually my distances are going to give me some idea as to what it's the near end or the far end. In this case, as I look at it, it's at an end. So I would do a visual inspection on the end to find what end is not terminated well and re-terminate that end. If I look at these distances, and I didn't put one in here as example, if this shows 3 meters, this shows 3 meters, this shows 0.5 meters, this shows 3 meters, well, it's going to be on the near end of the cable. I would check the near end of the cable for the problem. So the continuity is going to tell you it's open and which one to look at. A wire mapper is usually going to give you some kind of clue as to what wire is open and where. Well, this near or far end kind of thing. Almost sound like Grover there with near and far. So for finding that, again, I would look for those details to know what end am I inspecting, to know what end am I replacing or re-terminating. A short, again, this one is going to show what a wire map is going to show 2 pairs are connected or 2 wires that are connected that shouldn't be. My little continuity checker is going to show that a particular wire pair is shorted out. Again, that's usually caused by when I stripped the insulation off, I was a little extra exuberant, and I have some micro cuts in this case, the white orange and the orange wire, and when those got terminated into an outlet or an Rj45, those little micro cuts are laying next to each other and shorten the cable out. So the continuity checker is giving you an idea there's a short. The wire mapping meter is actually showing you what particular wires are together. And in this case, I would probably want to be checking. Well, I would probably start with the patch panel end. That's a little easier to see, and then look at the outlet jack end. A lot of times this does happen on the outlet jack end, not so much on the patch panel, because I terminate the outlet jack and I kind of shove it in an outlet box. In the process of shoving in the outlet box, sometimes some unnatural bending occurs. Connector open. This is showing all wires open on one end. The continuity meter is going to show a fail in total. As I go across every wire pair, it's going to say open, 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 open. Okay. The wire mapper is going to show that, hey, there's nothing there. So again, start checking your ends. I would probably start checking the patch panel end because it's easier to view. Get a flashlight in there and see. Maybe you put the punch down tool in backwards and you punched it in where you cut all the wires off before it made connection. That's easy to do. I've done it. It happens. But get a flashlight in there and so you can see well if that has occurred, and then go check your outlet jack end. That's a little harder to check. That's why I say start with the patch panel end. That's a little easier to check. If I have wires in the wrong positions, I might have a cross pair. And your cross pair is 2 wire pairs have swapped places. Orange and green, if you will. As a continuity checker, when I go through my fault check, when I do my first check, it's going to show fail. I go through the fault check, it's going to show 1, 2 is crossed, 3, 6 is crossed. So I know the oranges and green wires have flip-flopped. Same thing with our wire mapper here. I'm seeing the orange and the green pairs flip-flop. That is easy to do, especially if you pulled cables on Monday. On Tuesday, you terminated outlets. On Wednesday, you terminated patch panels. Well, Tuesday, you terminated the outlets to 568A. Wednesday, you go in the closet and you start punching in wires on 568B. Oops. You have created crossovers because you have mixed the color codes. So that would be an easy one to cause, or an easy thing to cause that to happen. Again, I've done it. Easy to do. So now you got to find the end that you caused it on and repair that end. And maybe it is the outlets, maybe it is the patch panel. Both ends, the color codes can be a little troublesome sometimes to read. So get a flashlight in there and look at it carefully. Maybe even take a marker and write over top of the color code you're not using, just so you can check things easier. I've done that too. Reverse pair, just one pair has flipped. So the green pair has flipped, or the brown pair has flipped, or the orange pair has flipped. Here, as I test with my continuity checker, it's going to fail. As I go through the fault check, it's going to show one wire pair is crossed, just one. Here it shows you cable with just the brown pair flipped. That has happened to me, especially as I do a patch cable. I do a patch cable and I slide the wires into the connector. That brown pair has flipped on you. Easy to do, easy to do. Find the faulty end, re-terminate the faulty end. Split pair is the toughest one out of there to kind of get your head wrapped around. But as we talked about it last chapter, this is actually a performance issue. So as I check, my little continuity checker may not pick it up. Many don't. My wire map is going to say something's not right. It's not until I use the certification meter is it really going to come up with, hey, you have a split pair here. Because this is what has happened. Normally, I have my wire terminated thusly. Okay? White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. And the reason I do, the 1-2 pair is or 1-2 pins are a pair, the orange pair. The 3-6 pins are a pair, the green pair. The 4-5 pin is the blue pair, and the 7-8 pin is the brown pair. That is normal. That's the normal pin out. Well, at first you probably felt it was very weird to terminate that way, but that's the way it goes. If you accidentally did what a lot of people do, okay, so this is the normal right here. Let me go to the next slide now. The next slide is what would be the temptation. The temptation is to go white, orange, orange, white, green, green, white, blue, blue, white, brown, brown. Just do the color pairs next to each other. Well, when you do that, you have created a split pair because 1-2 is still pinned up as a pair, meaning those two are twisted together and canceling each other. When you put white, green, green next to each other, 3-4, those wires are not a pair. It's the 3-6 that's a pair, and 4-5 it's a pair. So if I look at the 4-5 pin, yes, there's a complete circuit. I send electricity down this one, it comes back this one, but those two wires, the 4-5, are not twisted together to cancel each other. So that whole length of cable there is not twisted together to cancel, so I have lots of untwists. And the same thing is going to happen in the 3-6. 3-6 is supposed to be a pair, but it's not. Yes, electricity goes down here, it comes back here, but they're not twisted together. They're not canceling each other. 3-6 is not canceling each other. 4-5 is not canceling each other. So you have ripped two wires apart. You have ripped two pairs apart. Electrically, they're still connected, but performance-wise, they're not twisted together, canceling each other. So I have a whole slew of wire untwists is what it amounts to. So again, my continuity checker is going to be like, I don't think this is right. Your wire mapping is going to be like, I have connection, but something's not right. And it's not until you use this guy that it's actually going to say, look, you have split pairs between 3-6 and 4-5. And what you'll need to do now, again, here's your performance meter checking. It's going to show that it's not passing acceptable levels. What you'll need to do is literally re-terminate both ends of that cable run. That's the only way it's going to fix that. I have to re-terminate both ends of that cable run. The last thing they mentioned in the chapter is using a certification meter. Yeah, we've mentioned that a whole bunch in Chapter 9. We're mentioning it again now. The performance meter certification meter, I need to hook onto my cable run, the meter on, maybe the patch panel end and the remote on the outlet end. And it's going to run a series of tests, a battery of tests across that cable run to check for length, to check for attenuation, to check for near and crosstalk, to check for far and crosstalk, check for impedance. And if it passes all of those, it'll give us a summary here and give us a little pass of like, hey, all these are within acceptable levels. Bing, this cable run has passed. It is usable. It will be able to carry a gigabit of bandwidth, if you will. That needs to be done on all of our cable runs, and we will do that to our cable runs in the lab to certify that they're able to carry gigabit bandwidths. So there is Chapter 10.